Hi everyone. Today I want to talk about solving quadratics by completing the square. Let's get into it. So completing the square, we'll call it CTS from now on, is just another way or another method that we have to solve quadratic equations. Right? So we have solving by factoring, we've got solving by square rooting, we've got solving by a lot of different ways. The quadratic formula is something that we'll talk about later, but CTS is interesting. It allows us to solve any type of quadratic. Now, when I mean any type of quadratic, I mean any type of quadratic, right? So whether it has real solutions, imaginary solutions, integer solutions, rational solutions, whatever, CTS is going to help us do that. It's just unique. You'll see what I mean in a second. Okay, here's that uniqueness that I was talking about before. See how there's a 7 on this side of the equal sign? Well, we don't really like to have numbers on that side, right? We want to usually have 0 here. Unique, I told you. So let's go through the process of solving by completing the square, or CTS. The constant value, this negative 91, I am going to get rid of it and move it to the other side. Yeah, I said that. I'm going to move it to the other side. So I'm going to be actually adding 91 to both sides. Stay with me. Once I do that, oh, my green marker. Oh no, it's bleeding. Oh my gosh, this is really bleeding. Okay, that's bad. All right, the marker, not my hand. I'm fine, by the way. R squared minus 4r. Now, where we moved that 91 to the other side, there's an empty space there. But we're going to draw a box, or a square to be specific. That's not a great square. I apologize. When we have a space, we are going to make a square. And this is only going to happen one time. Well, twice in a second. It's going to happen again. But you'll see in a minute why we do that. That's going to equal the 7 plus that 91, which is 98. Now, in mathematics, what I do to one side, I must do to the other. So I'm going to put a square over there as well. Now, next step is I take the middle term, which is what the b term is actually going to be. And I take that term and I will divide it by 2. So I'll draw a little arrow, take the negative 4, divide it by 2, which provides me a negative 2. And then I'm going to square that result, which will give me 4. And whenever I square a negative, it's going to be a positive. If you put this in the calculator, like if we get some bigger numbers at some point, put parentheses around the negative and the value, because your calculator is going to lie to you and it's going to tell you that it's negative, which it never can be, right? Anytime we square anything, it's going to be positive. Now, once we divide by 2 and square it, the result that we get is the number that completes the square. So we're completing the square. Titan's amused. Now, the question comes up as, why are we dividing by 2 and why are we squaring it? Now, we're going to do that every time, no matter what happens. And on the next line, you'll see why we do that. So we're going to rewrite this part of the equation, but we're going to rewrite it with the 4 there, right? Itching my eye with my glasses because my eye's itchy. R squared minus 4r plus 4, right? Where that box was, I filled it with the 4. So that's why we draw our squares, so we know what is the number that completes the square. And that's going to equal 98 plus 4, which is 102. Okay? Now I've got something that's a little bit cleaner. So the reason that we divide by 2 and square the result is so on the left-hand side, we get something called a perfect square trinomial. Perfect square meaning I could square root all these things, you get one binomial value, and trinomial meaning 3 terms. So that's the reason that we divide by 2 and square the result. Now this part gets a little bit easier. It's just going to be parentheses r. The value right before we squared is going to be what goes in here. So when I say we want to factor this to get a perfect square binomial or a perfect square trinomial into something else, is we don't actually have to do any other math. If we remember the number before it was squared, that's the number that goes in here. I am going to put a square on top though too, because there's 2 of those. And that's going to equal 102. So now we've only got 1 or 2 steps left. To get rid of a square, I'm going to square root both sides. Getting rid of the square by square rooting just means that the square root I drew and the 2 go away. The parentheses also drop, so I'm just left with r minus 2. And that's going to equal the square root of 102. Here's more of that uniqueness that I talked about earlier. I don't want the decimal here. Now, certainly there are going to be some situations when the decimal's fine, but in this, I told you we're not using decimals. I just said 5 minutes ago, maybe 7 minutes ago, that we're not using decimals, huh? I know that they're not going to like it. You done? Sorry. He was not pleased at that. He didn't like that we weren't using decimals. He thinks decimals are easier, which they are, but we have to use non-decimals. We have to use things that are like, it's not interpretable in terms of like, when do I stop the decimal? I've got to use a radical. I have to. I'm sorry. I'm sorry, okay? All right, now, here's the idea about the square root of 102. We want to simplify the radical if we can. Now, when we do that, we look for a perfect square factor. But 102 does not have a perfect square factor. Yeah, it's divisible by 2, and probably a couple other numbers, but 2 is not perfect square. So we're actually going to leave it like that. So it will end up helping us in the long run. I'm going to add 2 to both sides. Now remember, it's the square root of 102, but it's the plus or minus version of that result. So when I add 2 to this, I can't add the 2 to the square root of 102. They're not like terms. So my answer is actually going to be r equals 2 plus or minus the square root of 102. And that's my final answer. So let's recap what we did. First, I'm going to add the constant value to both sides. Then I'm going to rewrite everything with empty squares where I moved that 91 to, or I moved that constant value to, and then 1 on the other end. Divide the middle term by 2, square the result, and the number that we receive or get after that is going to go in my squares. That completes the square. Then we factor the perfect square trinomial with the number that we already had, square up both sides, and then we'll get a result. Whew. Dude, stop looking at me like that, okay? I'm sorry about it, okay? He's just standing there. Let's move on. Let's try number 2. Again, same process. There's a positive 26 here. I'm going to subtract 26 on both sides. And that is going to leave me with x squared minus 10x square equaling 8 minus 26, which is negative 18. Square. Okay? Let's keep going. Take the middle term, which is negative 10. We're going to divide that by 2, which gives us negative 5. And I'm going to square that result, which gives me positive 25. That is the number that completes the square. All right? Draw a line underneath, and let's clean up this mess on the second level. We're going to rewrite this equation, or this nonsense, but the 25 is going to be in both of those boxes. Well, we'll put the 25 there, and then we'll simplify that part. X squared minus 10x plus 25 is going to equal 7. Now again, this is much cleaner than what we had before. I am going to factor the left-hand side only, but because the left-hand side is what we call a perfect square trinomial, all I need to do is put an x in parentheses, and remember that number before I squared it, which was negative 5. So x minus 5 squared is going to equal 7. To get rid of the square, we square root both sides, and I'm going to be left with x minus 5 equals plus or minus the square root of 7. Now, one more step to get rid of the negative 5, so x is alone, is I'm going to add 5 to both sides. We certainly can't break down the square root of 7. There is no perfect square factor that comes out of 7, and because that makes sense, the only numbers that multiply to get 7 are 1 and 7. Right? So my final answer, I'll write it over here, I don't think you can see it, will be x equals 5. Ooh, you can't see that anyway. How about here? X equals 5 plus or minus the square root of 7. And that's my answer. Let's try 2 more. Okay. So for these 2 problems, we're going to get similar answers, but we are going to have imaginary results. So when we square root these things at the very last step, it's going to look a little funky, but stay with me. Example 3. K squared minus 4k plus 1 equals negative 5. Same process occurs. I'm going to take this constant value, or the integer, on the left-hand side, and we're going to move it to the right-hand side. That is going to leave me with k squared minus 4k square equals negative 6 square. Take the b value, or the middle value, divide it by 2, which is negative 2, and I square the result, which is positive 4. That is the number that completes the square. I'm going to put them in both boxes. Right? Draw a line underneath, clean up this second level. We're going to have k squared minus 4k plus 4 is going to equal negative 2. Now, for those of you who got the eagle eye, right, that just honing in eye, you know what's going to happen. There's a negative number over here. That is not going to fare well for us at the very end here. If this number is positive, we'll have good results in terms of positive answers, real number solutions. But when I get a negative here, we're going to get an imaginary solution. And it's going to be okay. We'll work it out together. The left-hand side then gets factored. Parentheses k, and then the number before we squared it. So negative 2 squared equals negative 2. Square rooting both sides is going to leave me with k minus 2 equals plus or minus the square root of negative 2. Now, to the side here, we cannot leave this because we're not allowed to leave a negative under the radical because we're going to have an I, or an imaginary solution. So think about it like this. The square root of negative 2 can get broken down into the square root of negative 1 times the square root of 2. Well, we know what the square root of negative 1 is. That is the infamous I. So this is going to be I root 2, right? Or I times root 2. We just put them right next to each other. So this is going to be the final simplification of this radical, or that radical. So let's bring this up a little bit. We're going to be left with k minus 2 equals plus or minus I root 2, which is a lot cleaner than this negative 2 under the radical. Last step is we're going to add 2 to both sides, and we're going to be left with k equaling 2 plus or minus I root 2. And that is my final answer. Now again, we can't really add 2 to this value. They're not like terms. So I'm just going to put them next to each other, but the 2 has to go in front of the plus or minus. You can certainly try number 4 on your own. I'll go through it myself, and let's connect in a minute. You're back. I'm glad. Our final answer here is going to be n equals 2 plus or minus I root 58. Now, kind of like our previous problems, we're not able to, our previous problems, like the previous problems that we're doing here, like this craziness, like look at this, right? 58 is not able to be simplified. Now, certainly, there are factors of 58. 2 times 29 is 58 for sure. But neither 2 nor 29 are perfect squares. When we simplify radicals, we've got to pull a perfect square out, or they are not simplifiable. 58 is not simplifiable. On the previous screen, 102 was not simplifiable. So we're going to be left with that. Let's finish up. Things to remember about this video. Number 1, Titan is not a fan of radicals. He actually barked at me when I said we're going to leave it as a radical, which is an exact value instead of decimals. He's standing right there, right now. The actual number 1. Complete the square is a process with lots of steps, no doubt about it. But it will always give us the correct solution, if done well, for any type of quadratic function or quadratic equation, no matter what. It doesn't matter what the inputs are. It doesn't matter what it looks like. As long as it's quadratic and you use complete the square, it will always, always, always give you the correct solutions. Number 2, normal CTS answers will be in simplified radical form. But it depends on the context. You may need to get a decimal value to graph it, for example, and there may be some other instances where decimals are preferred. Normally, though, it's going to be a simplified radical, like we did today. And then number 3, got to make sure you remember to use the plus or minus sign. Anytime we square root any number, ever, it needs to be both the plus version and the minus version of that number. So remember that for next time. See ya.